Welcome to the study loop. So in this video we are going to discuss geometry of linear transformation. So for that we will consider an image of original house. We will discuss some transformations with help of this image. So beginning with rotations. The transformation to rotate an image counterclockwise about the origin by angle theta is given as this, as shown on the screen. So for our input image, the result will be something like this. It will be rotated by 90 degree in counterclockwise direction. Now about reflection. So reflection about x-axis, the transformation is this, and about y-axis the transformation is this. We can notice there is like a small difference about this element -1. It is here in the middle row, while here it is in the first row. So that is kind of a difference. So when our image is reflected over x-axis, it gives this result, and when it is reflected over y-axis, it's quite similar because our image is kind of symmetrical. Then we will see translation. So translate an image about a point tx ty, for example, that is to move the image by tx units along x-axis and ty units along y-axis. The transformation is given as this. So when an image is translated by suppose 3,1, we get this. So here it is not quite clear because we haven't mentioned the origin and the axis, but if we do mention it, it will be quite clear that the image will be moved from 0, 0 to 3, 1. The next is dilation. So the transformation to dilate image by dx dy, that is to scale the image by dx units along x-axis and dy units along y-axis is given as this. So for our image, when we dilate it by 1.5 and 0.75, so with respect to x-axis, we can say it is clearly more dilated than the y-axis because the amount is different. So yeah, this video is basically this much only. It doesn't really cover a lot of things. This chapter is like this much only. So to find these kind of transformations, we need to just consider, like, draw a rough sketch of the input and output, like what we want as output. Then consider the standard basis elements, and after considering the elements, then we will find the image with respect to the we will find the image of the input element with respect to the rough diagram, and then we will do the process of tu is alpha 1 v1 and alpha 2 v2, right? Like find the scalars for both the elements in the standard basis or whatever number of elements there are, and after doing that we will get the matrix representation. So basically that is how you will find all of the transformations that I have mentioned in this video. I haven't really done the step-by-step method for each one, but that is basically the idea. And in the next video I will be discussing the overall algorithm of all the topics that I have discussed till now. So thank you.